All right. So real quick, what we're gonna go over is the last week, what that assignment was, and it was to create the D cipher. Um, so that was, I mean, it was fairly simple. It was just taking this and flipping it, reversing it, and you just want to take it from, instead of going, like if you talk about this, you take ciphertext, make it to cipher number to plain number, plain number to plain text. Right? That's just how we're doing that decipher. We're just gonna run through it really quickly. This is recording, so if you need to go back through, you can check that. But we're gonna make the function for the decipher text key. It's the same variables that we used for the ncipher. We're gonna start it off. We're gonna say the ciphertext, and then we're going to just put that equal to an open string. Don't know why it's mad at me. You're right. Thank you. All right. So we have that text. We want to clean it. We're just going to run the text clean function. Text clean, and then text clean. Let's see, text. Okay. Next up, we're going to have put our alphabet. Obviously, alphabet's the same, so we can just drag this over. And that's good. So basically now we're gonna, it has pretty much the same system that the ncipher has, but reversed. So we're gonna say cipher character, we'll just say char for short. In the text, we want our cipher, another indent here. Gonna make our cipher number. This is gonna be equal to the alphabet dot find of cipher character. Basically, again, the find tool is looking in alphabet, it's trying to find what this character is. The character is like a letter, looking for that, and then it'll return the position in this string. Once we have that cipher number, what we're going to turn that into is our plain number, which is equal to, we're going to have parentheses here, it's our cipher number. This is where the main difference is, minus our key, and then we're going to have our modulo 26. Same modulo 26 for the same reason we had it up here, except now we're just having minus because we're working backwards. From that plain number, we can turn that into a plain character. We'll just call this plain char. And this is equal to the alphabet. And instead of dot find, we're going to use our square brackets, and we're going to search the plain number. Basically what this is saying is looking for this position that it's in, and it's going to put it into this, look for this alphabet, what position it is, and find the letter that it is. And then our ciphertext, you could call this output whatever you want, plus equals plain character. We are done with this for loop. We're just going to return. What we're going to do is block. I don't actually have the text block on here, so we won't bother with that. But we will have this ciphertext, and we're going to make it lower. Hang on. Oops, my bad. I mixed up this. This should be plain text and plain text. Okay. So now when it returns, it'll be automatically lowercase. Remember, plain text is lowercase. So if we try print, we'll just take the what we had from earlier, our Caesar decipher. Our text is, that didn't work, unfortunate. We'll just type it in, KHOORZURG, This doesn't need the text clean function, but I mean, it's nice to have it anyway. And our key was 3. So now if we run that, let's see. Hang on, what did I do wrong here? Undefined. It was reference before assignment. Oh, right, hang on. I forgot to replace this here with the plain text. As you can see, even though I have a script, I'm still messing up on my stuff and have to debug. Debug is a huge part of getting cryptography down and just programming in general. So don't worry about not being able to get stuff right the first go. Yeah, I'm just gonna leave it. It's not important. You guys get the point. It was just a typing error. So that was last week. That was what you guys had to do. I also provided a text block function so you could put it in the 5-piece chunks, which can make it look a little bit nicer. But that is enough about next week. What we're going to go through this week. Basically, what I'm actually going to do is I am going to take all of this stuff here. I'm going to bring this over to this side. We don't need to print this, but we do want to have these functions referenced in this module. This will be available for you after class. I will put this in the programming assignment stuff. So now you guys know how to decipher using a code, which makes it much easier because instead of having to go through by hand and find all the characters, you can just really quickly, test some stuff by just changing the number in this. But we want it to be even faster. Part of this has been, I received a hidden message and I know the key, right? So this doesn't always happen, especially with cryptography being like, cybersecurity in that area. And a lot of it was, most of these ciphers can trace back to war times. Like the Caesar cipher was from, during the Roman Empire messages, but there's other ones we'll get to were used during like the Second World War, stuff like that. So basically what those ones we want to do is I received a hidden message, but I don't know the key. So basically all you have is essentially gibberish, which for a Caesar cipher, there are a lot of ways you can do it. You can go through by hand, you can use character frequency, a lot of different ways, but we're just going to go through with this since we have this program. This is what's called brute force entry. You just have a computer run all the possibilities and just pick the one that looks correct. This is easiest for a Caesar cipher or a shift cipher because there are only 26 different keys, right? One for every, shift that you can possibly do. So for a Caesar, decipher, it is fairly simple. What I'm going to do really quickly is print. I want to get a freshly enciphered code. We're going to make our text something a little bit longer. My secret message that no one will ever know. And we're going to make our key 12. All right. So now we have, oh, hang on, I don't have the text clean of that. Real quick, troubleshooting. Text clean. Remember, if you get something like this, it's L is the 11th or the 12th position, so it's just shifting to that because it doesn't see these lowercase and uppercases matching. So just boom, like that. Now we got our ciphertext, but we don't really need to see that right here. We can just say message equals that. So this is now our message. It has this enciphered message that we have. We don't know what it is. So what we're going to have is a for loop. You could do a while loop. I'll show what it would look like if you did a while loop. We're going to try for key in range 26. You don't need to have the 0 there if you're starting from 0. What we're going to do is print the key, and then the Caesar decipher, we're going to use this function using message and the key. So this will work. As you can see, we have all of these, it says 0, so this is the ciphertext as is. It goes through, it tries everything, but you're running through, and then you see this one, 12, my secret message that no one will ever know. So that is just very, very quickly how you would do a brute force for Caesar cipher. One thing to note is that I did put the keys in the front just so that you would know. If I just put this, ran that, you just see all this and you say, oh, it's this one. Well, what's the key? Right? So that was the reason for putting that one there. But that was just a real quick brute force for Caesar cipher. We will be doing brute force for more advanced ciphers. I just want to give you guys the idea of what a brute force would look like. So we're going to move on. Big surprise to our new cipher that we're going to talk about. Also, really quickly, I'll show you the while loop for this. So what we'll do for the while is while key is, we're going to say less than, say 27, colon, and then if we print, or just grab this from up here so I don't have to retype it, it'll print that again. Oh, I forgot to have the key counting up. That's not important, you could figure that out, but I don't really care. For loop is better. You guys are great. We don't really use while loops in this because everything is for a specific range. But we're going to go over our next cipher because this is the brute force. I'll label that on there for people watching. All right. Next one we're going to talk about is multiplicative cipher. Basically, it is the same thing. Come on, that the Caesar decipher is, except if you might have guessed, instead of adding, it is multiplication. So basically, if you remember with the Caesar cipher, we started off and we took our characters. If we have A, B, C, D, those are the characters that correspond to 0, 1, 2, 3. Right? And then if we have our Caesar cipher, it just adds to each of these, so it could add the value to it and then it'd turn that back into it. But basically, for a multiplicative cipher, we multiply those numbers. So if, let's just say for simplicity's sake, we're doing by a key of 3. So then 0 times 3 would be A, 1 times 3 would be 3, which is D, 2 times 3 would be 6, and you get the idea. So it's pretty simple, and this is where the N cipher gets easier than the D cipher once we have multiplication, because it's not quite just easy as dividing. So, well, I say that it's not as easy as dividing because we're in the modulo of 26. Remember, that's how many characters in the alphabet, so we can't just do the minus modulo plus modulo. It's a little bit different for this. But I'm going to show you guys the N cipher. We're just going to call it the multi-N cipher. And then we just have, our only variables are, again, text and key. When we are going through this, we need to have our output. We're going to have our text equals text clean, and then again our text, and then we're going to need to borrow our alphabet, because that's still going to be useful. Pretty much every cipher we're going to have that reference to the alphabet in there. Alright, so this is going to look very, very similar to this Caesar cipher and cipher, this little for loop right here. So we're going to say for the plain text character, I'm trying to use different variables, in text, just like in the plain and the Caesar, we're going to say our plain number, is equal to alphabet.find of the plain text character. Same principle above. All this stuff pretty much carries through, and I'll just explain it at the end. Now that we have our plain number, we can find our cipher number, which is our plain number, and then we're going to multiply it by the key instead of add our modulo. Remember, multiplication is not x, it is the asterisk, the star. Once we have our cipher number, we can get our cipher character, which is our alphabet square brackets, just like before, and we're going to say our cipher number. All right, and then output plus equals cipher char. We're going to return our output. All right, so now that should be running. I'm actually gonna stop this right here. Now, what we need to do is we're gonna print it. We're just gonna try just a random thing here. We're gonna say mult and cipher. Also, if you want to know how I'm filling in, I'm hitting tab whenever it pops up. Our text, we'll just say location is so cool. It's the coolest, really. And then we're gonna make our key 6. That's something that's a little harder to see visually. So you can see I have an error with the indent right here. Let's see what's the issue with this. Hang on. I wonder if it's just being fickle. Any of you see an issue real off the top of your head? Not sure why this isn't working. We're gonna unexpected indented blocks. That means that there's an indented problem, which is just how the references all this good stuff. Maybe it's there. I don't know. So we're just gonna. I'm actually gonna grab this. So does anyone have? Well, first of all, does everyone understand the Caesar or the multiplicative cipher? Does anyone have any questions about that? If now, here's your go. Nope. Okay. So I'm just gonna real quick so we can move on here. Grab the encipher from my other page. All it did was, that's what I already have. It's just we don't have the text clean anymore. Okay, so now if we run that, it doesn't work because this hates me. So that's super cool. Sorry about this. Sure, no problem. You can head out. This is again recorded. Those of you who are watching the recording, this is fairly obvious. Oh, I see the problem was. It's right here, this for loop, I think. This for loop was active, so this was defined. There we go. Now we're seeing our issues in here, which I have just a name issue. There we go. Okay. So that's just
shows one of the dangers about just marking stuff out. You can see I had this open, so what was inside this for loop technically was this function. Basically, it was saying it needs to be indented if it's in this for loop. So, sorry about that little delay, guys. So this is our Encipher tool, and it is, I mean, it's fairly simple. Off of the top, you can really see the only difference between this and the Caesar Encipher is that it's a multiplication instead of a plus here. So basically, we're going to move on to the decipher. Now the decipher is a little bit more difficult because you can't just, we're not just going to divide by this key. We're going to find the inverse. So when you're finding an inverse, does anyone know how to find the inverse with modulo of 1? How we use normal numbers outside of cryptography? Feel free to unmute and chime up if you know how we find inverses. All right. No. Right. Yeah, exactly. So it's flipping it. So if you have a graph that's like a parabola, an upward pointing parabola, if you flipped it, it would kind of be a sideways pointing parabola. It flips over the line y equals x. So the inverse is just something there that number is on the denominator beneath 1. And in our regular world, I'll show you guys an example here. So in the inverse of, we'll give, for example, 3. The inverse of 3 is 1/3. So if you look at that, you're basically flipping it over the fraction. The inverse of 3 over 1 is 1 over 3. And the way you can tell that is if you multiply them, and you say, I'm actually going to do an easier fraction here. We'll say 4. So I don't have to deal with that repeating. So inverse of 4 is 1 over 4. So if we print 4 times 0.25, which is the decimal of 4, we get 1. What makes something the inverse is that when multiplied to the original, it equals 1. So this is different in mod 26 with the alphabet because, like I said, the modulo is 26. The modulo isn't just regular 1. So when we have a multiplicative key, we're going to say of like 15, something that's much higher, right? If there is a letter in here that is further in the alphabet than B, it will be outside the range of 26, which, as you can see, except for this letter right here, everything is outside of the range of B. So the modulo putting it into that is very easy, but it's a little bit more difficult because you want to find the inverse to put it back in. So how this applies is we're going to multiply the number by its inverse in modulo 26. So what I'm going to do is going to give you guys a function to find that inverse so that you don't have to by hand go through that. As you go through, if you did do it by hand, you'd eventually figure out what some of the things were, but I don't want you guys to have to do that. This isn't not going to make you memorize a times table. So we're going to start this off with the inverse finding function. Now this one I'm just going to kind of run through, and then it'll look a little bit strange. So this will be in the in modulo 26. That's the only modulo we're going to need for this class. You won't need this function for another value. We will only be using the English alphabet. All right, so we're going to have our inverse of the key, because the key will change. The inverse of the key will change depending on what you have. And we're going to go through. We're going to say for number in range 26, again from 0 to 26. And we're going to say if the number times the key, we're going to say modulo 26. If that is equal to 1, then what we want it to do, remember this is an if loop, so we need to have another indentation here, is return the number. So this would just find for any given key what it is. The reason we have this modulo 26 here is because it's not just regular. So if you default, I don't want to say like the default world number, but we do all of our math, all of our numbers in modulo 1. So let's just say our number was, I don't know, 2, and our key was 4. These are numbers I'm pulling out. I don't know what they are, the inverse actually. Then multiplied does not equal 1. But if it equals 1 in this given modulo, then that is our inverse. So that is just, we're going to incorporate this with our multiplicative decipher tool. Except we're just going to leave that. If we run that, it should just work fine. Yes. So now we have this function available to us if we want to call on it later, if you guys need it for something else. But for the context of the multiplicative decipher, mult decipher, I'm just going to build it into this function so you don't have to call something twice and have 2 of these in there. We're going to have our text and our key again, still the only 2 variables we have. I'm going to go through here, our output. Also, I like to double indent. That's complete sheer preference. It just makes it look a little easier for me to see it when they get longer. Our output, empty string again. We're going to have the same text clean and alphabet. What will be coming in here will be an enciphered text, so it'll already be uppercased, but it could be in the blocks, which have the spaces every 5 characters. So it is important to have that alphabet in there just in case. We're going to say our M inverse. We're just going to call that our multiplicative inverse. We're just going to set this equal to -1 for right now. We need to set this to an integer value before this we call on it for the function, but I just want to make sure that it's -1 so we don't forget about it. We're going to have a for loop for the number in range, again, 26. We're basically just taking this up here. We're saying if our number times our key, again, modulo 26, equals 1. Equals is just for like these inequalities. If you have equals, it's more of like a reference variable name setting, but equals is for checking this if this is a true. This is a Boolean. This equal is a Boolean. Other examples of Booleans, quick sidebar. Other Booleans are, less than, equal to, greater than. And you will see some of these in the, if you're doing work with Unreal Engine, they are very helpful there. But we will continue with this. Our equal to Boolean, and then we're going to set our M inverse that we created up here. We're going to set it equal to this number. We've found that this number is the one that makes our key equal 1 in this modulo, so we want to make sure our number is saved as that inverse so we can call it later. Now we can get out of this for loop, out of this if loop, or if statement, and we're going to go to another for loop. And now this is, from here on out, it is pretty much the same thing that we have here. I'm sorry if you can hear my dog in the background. She's very scared. So we're going to start with a cipher character in text. And then from here, we have once we have our cipher character, we can find our cipher number. By finding the cipher number, we do the same alphabet dot find of cipher character. This is not new. and we go down. Once we have our cipher number, we can find our plain number, which is equal to the cipher number times the M inverse that we found. And then again, we want to do the modulo 26. Plain character equals the alphabet, and we're going to do the brackets again, square brackets, of our plain number. Actually, I want to make this unique. Plain character. So this is just for going through the same way. We had our cipher character, cipher number, to plain character. Now we have our plain character. We're just going to take our output that we labeled earlier plus equals our plain character. Character to number to number to character to text. Once we enter here, we just want to have our return. I want to make sure that it's in the same line that this indent is. We're going to say our output, but again, this is coming out as a plain text, so we want to make sure it is lowercase. Gonna just run that, see if it has any errors. No, that worked. Yeah, I believe it's Murphy's Law. If something will go wrong, it will. But not this time. So we're gonna try this out here. We're gonna say our, what we're gonna do here is actually, I'm gonna take this out, and we're going to say that our cipher equals this, and we're just gonna print. This is just so I can have a reference of it, because you guys could see earlier that I had some trouble typing it in. As these get longer, it's a lot harder to, and that's the point of cryptography, is that once you get, a sizable message, it should be hard to break into, because that's classified. All right, so now we're just going to use this enciphered text that we had earlier. I'm going to say mult decipher. Our text is that CIPH ciph, and then our key is, we want to use the same key from before, so 15, and then we just run that, and there it is. Multiplication is so cool. So you can see how this is a little bit trickier, and we're starting to get into the meat of cryptography. It's no longer just you can kind of look at them or go through on a pad and pencil and you just work backwards. It's still technically working backwards, but as we get further, it'll get incrementally harder. This is still week 2. I don't count that first week. So if you have any questions, of course, please stop me now. Feel free to DM me. Make sure that you guys understand. I don't want anybody left behind trying to figure out how the multiplicative cipher works when we're going into binary. If there are no questions, I will go ahead and describe the next cipher, and then your assignment will be to create an end cipher for it. The name of our next one is Affine cipher. Affine cipher shouldn't be hard, hopefully. Here's hoping. Because Affine cipher is a combination of the multiplicative encipher and the Caesar encipher. Basically, what the Affine cipher is you have it's a multiplicative cipher, but with an initial bump, right? Allow me to explain. So if we take this and we look here, it goes through and these spots get larger. If we said our first letter was A in this, and we ran it, you can see cipher and cipher, it's A because 0 times whatever key we have is still 0, so it just goes through. On top of that, it just is one more step secure, because there's just one more thing you have to do in order to encipher and decipher something. So I'm going to tell you guys how this works. You have the same alphabet modulo. It's the same process. It should look very, very similar to this chunk that we've seen over and over again. Basically what you do is, instead of just multiplication or just addition, you're going to say our plain, we're going to say, our plain text number, which, we're looking at this phase right here. Sorry, I'll look on the ncipher. I'm going to show you guys how this line works. This line is where the actual like enciphering or the deciphering happens. So I will give you guys the theory on this one, and then hopefully you guys can work this one out. I'm giving you guys less to work with, so hopefully this is kind of just a test to see how it does. Let me know, of course, if you have any trouble. So you're going to take your plain text number, you're going to multiply it by what's called an M key, simply multiplication key, multiplicative key. And then you're going to add that with an A key, addition key, additive key. You want to make sure it's formatted like this. You can have these two swap, but you want to make sure that multiplication happens first. You don't want to have parentheses, plain text plus A key, close parentheses, M key. That will give you the wrong thing and you're doing something else. And then once you're here, you're going to take all of this, the resultant, and modulo 26. From there, it is the exact same. Like I said, I'm giving you this line. I want you to have all of this. A lot of it will be the exact same. But this is, I just want to, sort of put my foot in the water. That's officially all that there is. I will reveal the winner of this week's raffle shortly, not during class. And then that will be it that we have this week. If you have any questions, of course, DM me. I will be releasing more videos that need help and give more theory on stuff for people who miss class.